This is the combustion of natural gas. My name is Christian Garza. This is for my chemistry project for Chemistry 1311 or General Chemistry 1. I'm just going to jump right into it. This is just pretty much telling you about some of the economic, environmental, biological benefits and some downsides of the use of natural gas. First off, we have the natural gas reaction. So this is the very generic reaction for methane. Methane is CH4. It is the most common natural gas that we use today. So yes, this is just a standard reaction. There could, in the real world, there's probably some other stuff that's thrown in here, but, for this project's sake, this is just the very generic version. So this natural gas is burned in excess oxygen to form carbon dioxide and water vapor. So whenever you have a combustion reaction, we're always going to get CO2 and H2O, but these are all in gaseous forms, so water vapor and of course CO2. And a fun fact for methane, it actually burns at an average temperature of around 1200 to 900 degrees Celsius. So it's pretty up there. It's pretty hot. And then the most common natural gas is methane, CH4. It accounts for about 70 to 90% of all the natural gas that we use today. So it's pretty common. What makes natural gas different? So methane produces much less particulates. So particulates are pretty much physical wastes, such as when you're at a campfire, it produces charcoal, ash, stuff like that. So physical wastes that are produced in the environment due to the reaction. So methane produces a lot less than coal, oil, and other oil-based fuels, such as like fuels that are derived from oil, like gasoline, and so on. Methane is composed with much lower carbon, nitrogen, and sulfur ratios. So this pretty much goes into the complexity of the molecules. So methane has a lot less carbon, nitrogen, and sulfur in its molecule, so it would produce a lot less carbon, nitrogen, and sulfur-based wastes, such as like carbon dioxide, nitrogen dioxide, and other, and sulfur-based wastes as well. So this would help limit smog production due to less nitrogen waste. So smog is pretty much a photochemical reaction where its key component is nitrogen. In the summertime, most cities get a higher smog. Well, you notice smog more often in the summertime because of, the sun's out longer, it's hotter and stuff like that, and so it produces a lot more smog. The biological and environmental effects. So, when it comes to the biological impact, first thing that we usually talk about is, global warming and how it affects the environment. And the greenhouse effect. Unfortunately, methane by itself is a very potent greenhouse gas. It's about 21 times better at trapping heat than its other fuel-type counterparts. However, this is methane by itself. This isn't the byproducts from burning methane. So, methane produces significantly less carbon dioxide, with the exception of carbon monoxide. They're two different things, and methane actually produces a little bit more carbon monoxide than its other counterparts. However, carbon dioxide makes up the majority of all the greenhouse gases that are produced today. So this, in general, would be overall a less potent greenhouse gas to use, as long as we're not, throwing methane by itself into the atmosphere. Methane has a cleaner footprint. So it produces a lot less nitrogen, mercury, and sulfur products, which are key components in acid rain. So it could help with a lot of the biological impacts that are caused from acid rain by itself. And then the last topic is economic viability. So for the longest time, oil, coal, and other oil-based products have been used mainly because it's so vast. It's so plentiful, and it's been the cheapest option for, decades, even centuries. So, it's been a very big part of human development. So, methane has been kind of a newer gas that has been discovered, and so it's been kind of put on the sidelines for now until we kind of get a better option for it, and a better way to produce it. So 81% of the U.S. pollution is caused by oil, coal, and oil-based fuels, mainly because it's so deep in our history, and we've been using it, for decades. That it kind of makes sense. Natural gases have dropped to a competitive value in recent history. So, if you were to buy a barrel of crude oil, it would cost you around $45. And for 1,000 cubic feet of natural gas, costs you around $11. So I've already done the calculations for this. So for a comparison, a standard barrel of oil is 42 gallons, which is actually equal to about 5.6 cubic feet. So for $45, you get 5.6 cubic feet of oil, and for $11, you would get 1,000 cubic feet of natural gas. So there seems to be quite a large margin at that price point. And then finally, I have my sources here. This is the two main websites that I got most of my information for this project from. Naturalgas.org goes into the natural gas, information and history, and then EIA is like energy prices. It goes hand in hand with the stock market as well as some raw materials. So go check those out. And yeah, that's my project for this semester. Thank you.